Welcome to the session. We're really excited to share the information with you around the skill shortages in the engineering labor market, as well as some of the research that OSPE has conducted. We hope that it'll be a valuable session for you. To begin, we just wanted to take a moment to acknowledge the support that we've received from the Government of Ontario and the Government of Canada. Thanks to their funding, we've been able to conduct the research with engineering employers across Ontario and develop some supports for employers around some hiring and recruitment challenges that they may be enduring. Today's outline, what we're going to try and cover over the hour that we have with you, we're going to start off very quickly and share a little bit about OSPE, who we are as an organization and what our mandate is. From there, we'll talk a little bit about the labor market trends and skill shortages to provide you with an overview of what we see as the circumstances in the engineering industry at the moment. We'll also touch on OSPE's research that was done with engineering employers across Ontario. From there, we'll talk a little bit about how we see OSPE being able to support employers through things like the Engineering Employer Resource Hub and some other things that we'll touch on. We'll also, throughout the session, be monitoring the Q&A chat pod. So again, if you have any questions as we're going through the materials, don't hesitate to send a message through that chat pod, and we will have John, our presenter, address them. So a little bit about OSPE and who we are. We're really we see ourselves as the voice of the engineering profession in Ontario. Currently, we have about 10,000 members that have chosen to be a member of our organization. And really the work that we do supports more than 200,000 professional engineers across the province. When we think of what it is that we do as a society is we really see it as advancing the professional and economic interests of all Ontario engineers. So we support engineers of any discipline and any industry. Finally, we do a lot of work in terms of advocacy, speaking to the government a great deal, the industry and the public, to really raise awareness about what the role and function is of engineers in Ontario. At this point, I'd like to pass it on to John O'Grady. He's the researcher that OSPE worked with to do some of the research with employers in Ontario. And John is a partner at Prism Economics, which is a labor economics research firm. So without further ado, here's John.
Thank you. What I'm going to explore with you today is looking at the nature of skill shortages in a professional engineering labor market, what's causing those shortages, why they're systemic or chronic rather than just cyclical, and then also look at some of the report some of the findings of research that we have done looking at the role of internationally trained engineers in helping to address or at least partially alleviate those skills shortages, and explore also some of the reasons why employers may not be taking full advantage of the possibilities of that particular talent pool. I want to start though by just setting some context. Labor markets for professionals like engineers are different from other kinds of labor markets. What's distinctive about them is the very particular role and particular importance of skills and experience. And you see that often when you are recruiting. You may post a vacancy. You'll receive large numbers of applications typically for that vacancy. Many of them will be people who at least have the formal educational qualifications that you're looking for, but they will not have the particular skills and experience, in particular the experience that you're looking for. And so what's characteristic of a professional labor market, like the labor market for engineers, is the difficulty that employers so often experience in recruiting people who meet the skills and experience profile that they require. So what we're going to look at today is what's driving that skill shortage, what are the factors behind it, and then also the role of internationally trained engineers in at least partially or potentially alleviating that skills shortage. I want to start, though, with just summarizing some of the third-party evidence that confirms the finding that emanates from our own research about a systemic skills shortage affecting the engineering labor market. Exhibit number one, as it were, is the results from a survey that was undertaken by the Canadian Manufacturers and Exporters, the CME, and their members, 26%, reported that they were currently facing shortages in recruiting scientists, engineers, and R&D technicians, and more than a third, 35%, indicated that they anticipated that they would face shortages over the next 5 years. What's interesting to note about that survey is that it was undertaken in 2012 and 2013, and those were years when the economy in Canada and Ontario was not especially strong. There's no particular reason, given economic conditions, why employers should be experiencing those kinds of recruitment difficulties in what is otherwise a weak labor market. But as I had said, professional labor markets are different because of the particular and the important role that's played by very specific kinds of skills and experience. Another piece of evidence confirming the skills shortage is a report that was published by the Canadian Imperial Bank of Commerce. And they listed 25 occupations which showed signs of skills shortage, and you will see on that list that there are a number of engineering occupations that rank high on that list as occupations where there are clearly signs of skills shortage. Third piece of research comes from the Ontario Chamber of Commerce. They undertook a survey of their members, and they found that a significant percentage of their members were having difficulty finding people with the right skills profile, with adequate skills. And you'll note in their survey that right at the top of the list are employers who are in the engineering and infrastructure field. And indeed, broadly, if you look at the list of employers that are experiencing a greater degree of difficulty, they tend to be in more technology-intensive sectors of the economy. We can also look at a survey that was carried out by the Conference Board of Canada, and they asked employers about the occupations which they expect to have the most difficulty in filling over the next few years. And you can see that right at the top are engineering professionals. So the question I think we need to ask is, what's the nature of this skills shortage and what's driving it? And in terms of the nature of the skills shortage, the research shows that it's systemic or chronic. In other words, it's not cyclical. It's not going to go away. It's a systemic shortfall between the demand for experienced engineers and the current and the projected supply of experienced engineers. And the emphasis here is on experienced engineers. That is to say, engineers who have been in the labor market for a minimum of 3, preferably closer to 5 years, and have acquired that very important experience dimension to their skill profile. So what's causing this chronic imbalance between the demand for experienced engineers and the supply of experienced engineers? On the demand side, there appear to be 4 drivers. We'll go into those in a little more detail in the course of this presentation. I'll just list them now. There's the increasing technology intensiveness of the economy. There's an increase in capital spending, which is particularly important in the demand for engineers. There's the impact of globalization, and the particular dimension of that is the way in which it increases the demand for the export of engineering services. That is to say, engineers who are based in Canada but who are providing their professional services to international clients or on international projects. And fourth, of course, is replacement demand, which is largely being, being driven by retirements. On the supply side, the problem appears to be a systemic shortfall in the number of junior engineering positions, which is the first rung of the ladder for a recent graduate from an engineering school. If you have a bottleneck there, then it's inevitable that you will not have enough people going up the ladder and becoming experienced engineers in order to replenish the pool of experienced engineers as it is depleted by various forms of attrition. This graph is a summary of projected demand for engineers, and it's based on quite an elaborate forecasting model that we have developed for the engineering profession. And the particular message that's important from this graph, you'll see that Ontario there is highlighted on the graph, and Ontario is projected in itself to experience moderately significant growth in demand for engineers. But you'll note that there's much more significant demand in Western Canada, and the significance of that is that the demand in Western Canada acts as kind of a gravitational pull on the supply of experienced engineers in Ontario. And so engineering recruiters here in Ontario, in a sense, are in competition with recruiters in Western Canada who are seeking the same kind of talent and often in a position to pay a salary premium in order to meet their skill needs, particularly in the resource industries. This next graph is an estimate of the demand for engineers that would be triggered if there was a significant increase in the international demand for Canadian engineering services. In other words, if in particular the emerging economies, Brazil, China, Indonesia, Mexico, experience an increase in engineering-intensive projects and therefore require the professional services to support those projects. And the outcome of that analysis is that it has a very significant and highly disproportionate impact on the demand for engineers in two provinces, Ontario and British Columbia. So that if there's a resurgence of international demand, as is expected for professional engineering services, recruiters in Ontario will experience a spillover effect of that demand. I want to now just look at a little more detail at some of the demand drivers in the engineering labor market. And you can see on this graph what we've done to illustrate what really are basic changes that are occurring in the economy. There's two lines on the graph. The first plots the change in employment in technology-intensive occupations, what Statistics Canada would call natural and applied science occupations. And then the second line, the green line, plots the change in employment in all other occupations. And when you compare the two, you can see that over the last couple of decades, the rate of growth of employment in technology-intensive occupations has been substantially greater than the rate of growth in all other occupations. And that reflects underlying changes in the economy, which make the economy simply more technology-intensive as time passes. The second driver that I had mentioned in the introduction is capital spending. And capital spending is particularly important for the engineering labor market because it affects so much of the demand for engineering services. Engineers are involved in the initial feasibility studies. They will be involved in environmental assessment studies. They'll be involved in the design. They'll be involved in the commissioning of new investments, and they'll be involved often in the management and operation of those new investment assets in machinery, equipment, buildings, and so forth, infrastructure. What you see on this graph is that for a very significant period of time in the 90s, capital spending in Canada was comparatively flat. And then by the latter part of the 90s, it ratchets up quite sharply. And there's a very rapid growth in capital spending in Canada that goes on for some considerable period of time, and indeed it carries on until the international economic downturn in 2008. There's a dip in capital spending, and then there's a fairly sharp and complete recovery in capital spending. The rate of growth is still hasn't moved back to where it was, but in absolute levels, it has moved back to where it was. What's important about this is that from roughly the mid-1990s onward, you see that surge in capital spending, and associated with that is a surge in demand for experienced engineers, because capital spending is the single most important determinant of the demand for professional engineering services. The third driver that I referred to was globalization, or as it affects the engineering market through the export of professional engineering services by Canadian-based engineering firms. And you can see on this graph that it plots the exports of engineering and architectural services. That's the statistical category, although it's overwhelmingly engineering services. That's the red line. And then on the blue line, you can see the imports in engineering services. And what's important to note here is that the export of engineering services increased much more rapidly than the import of engineering services. Indeed, the export of engineering services grew almost 3 times as fast as the import of engineering services. That means that there are particular skill profiles that are especially affected by the international demand for engineering services, and those tend to be in the fields of energy, infrastructure, mining, and materials that have a particular impact in the Canadian engineering labor market, because those skill profiles are in much greater demand as a result of the need to meet requirements in the international engineering market. Another indication of just how important the international market is for Canadian engineering comes from a ranking that is done by the Engineering News Record, which is a weekly publication that tracks the engineering business, published by McGraw-Hill. And what I would like to draw your attention to here, what this table does is it estimates the share of the international engineering market by country. And what I would like to draw your attention to is a particular comparison between the United States, which not surprisingly has the largest share of the market, just under 35%, 34.9% of the market, and Canada. Now, Canada is basically 1/10 of the size of the United States. Other things being equal, if the United States has a 35% share of the market, you would pretty much expect that the Canadian share of the market would be around 3.5%. In fact, it's 7.4% of the market. In other words, it's more than double what you would have expected given the size of Canada relative to the United States. And that's an indication of just how disproportionately important to Canada and to Canadian engineering the international marketplace is, and the effects of that marketplace on supply and demand for engineers in Canada, and the kind of salary premiums and skill shortages that can emerge in Canada, and in particular here in Ontario. The fourth driver that I referred to in the engineering labor market is the replacement demand. And the way to understand that is to think of the pool of experienced engineers who are working in engineering jobs. And so those are engineers who have a minimum of 3 to 5 years of practical engineering experience on top of their formal educational qualifications. And that pool is subject to attrition. First of all, there are people who are simply promoted out of engineering jobs into either engineering management or general management positions. There are people who leave the engineering labor force and move into non-engineering jobs. There are people who will leave the engineering force either temporarily or permanently for reasons of family responsibilities. And of course, there are people who leave the engineering labor force because of mortality and retirement. And what has happened over the course of the last 10 or 15 years, but it has picked up momentum, is that the depletion of the pool of experienced engineers as a result of retirement in particular has increased. And so the pool is depleting at a faster rate than it has in the past. To get some idea of the vulnerability to depletion of the pool as a result of normal demographic factors, take a look at this graph. What it does is it shows the percentage of engineers broken down by discipline who are age 55 or over, which means they're in the age cohort that is either eligible for early retirement or in the age cohort that is moving towards retirement. In some disciplines, the percentage is comparatively low. Not surprisingly, in computer engineering and software engineering, it's a comparatively small proportion of that workforce that is in the age 55 or over cohort. But when you move through to some of the other disciplines, in particular mining engineers, mechanical engineers, electrical engineers, it's a much more sizable proportion of the workforce in those disciplines, which is age 55 or over. And so the depletion of the pool of experienced engineers in general is accelerating, but it's accelerating with particular emphasis on certain disciplines that are experiencing the impact to a greater degree. Well, now let's look at the supply side, and why isn't it the situation just rectifying itself? Why isn't demand creating its own supply? To answer that question, we have to investigate and ask what happens to the cohort of engineering graduates. How do they fit into this equation of shortage? And the best evidence that we have suggests that roughly a quarter of the graduation cohort will go into engineering jobs, junior engineering jobs, as you would expect. Those are jobs that, at least in the regulatory sense, fall under the Professional Engineers Act. The graduates who go into them will be in jobs that are typically understood as junior engineering jobs. They will acquire the engineer in training status with Professional Engineers Ontario, and they'll be moving forward towards licensure. Another 10% or so of that graduating cohort will go into jobs for which an engineering degree is a common requirement, but it's not necessarily a job which is regulated by the Professional Engineers Act or one for which the employer would require a PEng designation. And some of those graduates may enter the licensure stream with PEO and become engineers in training. Others may not. Then there's a much larger segment of the graduation cohort. Somewhere our best estimates are between 45 and 50%. And they will go into jobs, many of which may have a professional status. They will go into jobs that are not performed uniquely by persons with an engineering degree. An engineering degree may be a valuable qualification, but it is not a qualification that's uniquely required in those jobs. And often they are jobs for which the person has also picked up an additional qualification such as a master's in business administration. And then there's another segment of the graduation cohort, about 15 to 20%, who simply go into other jobs that are unrelated to applied science and technology. So the particular message from this chart is that of the graduation cohort, only somewhere between 25 and 35% enter the stream that you would associate and define as engineering jobs or closely related to engineering jobs, and potentially, therefore, become the kind of experienced engineers who can replenish the pool as it is depleted by the various types of attrition. If we pull that together and try and do what we'll call the arithmetic of the skills shortage, the annual projected hiring demand for new engineers that is generated by the drivers of growth is about 850 persons. The replacement demand that is generated by the various types of attrition from the pool of experienced engineers is about 4,200 per year, so that the annual hiring requirement is somewhere in the range of 5,050 by these calculations. The flow of new graduates into the engineering labor market, that is to say those who go into engineering jobs or jobs that are for which an engineering degree is a common qualification, is about 3,200 to 3,700. And so the supply gap appears to be somewhere between 1,350 and 1,850 on an annual basis, and that accumulates over time. And so what you can see from that kind of arithmetic is that the shortage of skills in the engineering labor market is really systemic. It's not going to correct itself any time in the foreseeable future. In fact, it's likely to get worse. How do companies deal with this kind of a situation? Well, there appear to be 6 human resource management strategies that companies turn to when they have to deal with a skill shortage. They can put in place various retention strategies, which will, at least in the short or medium term, lessen their risk of attrition. They can, if they're large enough, expand the number of junior engineering positions so that they're able to replenish their own pool of engineers as it is depleted by the natural forces of progression and attrition. Some companies, some employers are in a position to pay above the market. The effect of that, of course, is to shift the burden of dealing with skill shortages onto other employers who are not in a position to pay above the market. Some companies, at least for a short term, it's not really a sustainable strategy in the long term, will try to meet their needs through more overtime or longer hours. Some companies will turn to using temporary foreign workers as a kind of a stopgap strategy, which is also, and we'll say a little bit more about this next couple of slides, the use of temporary foreign workers, which is fairly important in the engineering labor market, is also an indicator of the severity of the skills shortage problem in the engineering labor market. And of course, employers can also turn to the pool of internationally trained engineers, those who arrive in Canada as permanent immigrants, to meet their skills strategy. One way or another, faced with this kind of skills shortage that is systemic, companies will have to adopt one or more of these stratagems in order to deal with their own skills requirements. I referred in the previous slide to temporary foreign workers, and this graph is indicates two things. The first, the red line, shows you the number of persons who immigrated to Canada with engineering qualifications and had stated their intention as being to work as a professional engineer. And you can see that the number of people there peaked around 2000 and then fell back quite dramatically. The blue line indicates the number of people who came into Canada as engineers under the temporary foreign worker program. And you can see that that took a jump in the mid to late 1990s. But what's particularly important is if you look at the end of the graph here, you can see that the temporary foreign worker program now supplies more engineers on an annual basis than the immigration system. In fact, for every one engineer who arrives in Canada under the permanent immigration system, more than two come into Canada as temporary foreign workers. There have been some changes announced to the immigration system, which may, in the longer run, address some of your skill needs. For example, they've announced that the standards for English or French language competency have been increased, and that applicants for immigration will have to have their language competency tested by an independent and recognized testing service. There's also been an increase in admissions under what is called the Canadian Experience class, and that chiefly enables more persons to come in or to become permanent residents of Canada when they had previously acquired Canadian experience either as students on a student visa or as temporary foreign workers on a temporary work visa. And the Federal Skilled Worker Program, which is the primary channel through which people with engineering skills immigrate on a permanent basis to Canada, some changes to that program are also relevant. The language proficiency requirements have been strengthened and given more weight. Canadian experience requirements have been increased. There's reduced weight for non-Canadian experience. And they've also announced that, the federal government's also announced that it intends to introduce a new system called the expression of interest system, which will replace the current way of processing applications for immigration to Canada. The current system operates essentially on a first order of submission principle, first come, first serve. And that's what then leads to sometimes the accumulation of significant backlogs in unprocessed applications for immigration. The expression of interest system operates quite differently. In this system, when it is put in place, as is the intention over the course of this year, persons who are contemplating immigrating to Canada first submit an expression of interest, and in that expression of interest, they provide information on their educational qualifications, their employment experience, and so on. And that expression of interest is then evaluated against criteria that are particularly sensitive to current skill needs and hiring challenges in the Canadian economy. So this is where employers have a more direct input into describing the skill needs that they are challenged in meeting. The expressions of interest are then evaluated in terms of those skill needs in the Canadian economy, and they're also evaluated against one another and the more highly rated expressions of interest are then invited to make an application for permanent immigration to Canada. Those which ultimately are not ranked sufficiently high are simply dropped out of the pool so that backlogs do not accumulate. This system is intended to make the immigration intake on an annual basis more sensitive to, more responsive to some of the actual skill needs that prevail in the Canadian economy. What I want to turn to now is internationally trained engineers, that is to say, persons who obtain their engineering qualification outside of Canada. And at present, internationally trained engineers comprise about 37% of the potential engineering labor pool. Most of them, although not all of them, are experienced. And one of the challenges, one of the puzzles, is that this pool of potential talent appears to be underutilized. And so what we wanted to do was to delve into the nature of that talent pool and look at some of the potential impediments or obstacles to its more complete utilization. If we look at where folks are from, internationally trained engineers, we find that about 38% immigrate to Canada from a jurisdiction in Europe, and about 16.5% have a South Asian origin, and about 15% from China. What's interesting to note about this pattern of sourcing is that engineering in many of these countries is undertaken somewhat differently than it often is in Canada. In Canada, North America more generally, the predominant organizational model is the team, minimum hierarchy team. In many of these other jurisdictions, the organizational model tends to be more functional, tends to be more hierarchical, and consequently, how internationally trained engineers understand the role of an engineer and interpret and explain their experience can be somewhat different from those from a Canadian trained or a North American trained engineer whose experience is derived in a team model. They'll articulate and describe their experience often differently, and if your recruitment strategies are not sensitive to those nuances, you can sometimes miss opportunities to identify talent that could meet your skill requirements. One of the other factors that's of interest about internationally trained engineers is that, in general, they tend to be about 6 years older than domestically trained engineers. That reflects just the profile of when people immigrate to Canada. But that means that, on average, most internationally trained engineers have about 6 years more experience. Admittedly not Canadian experience, but have about 6 years more experience than their Canadian counterparts. So let me just describe for us what we think is a kind of a disconnect here, or a puzzle. We know that there's a systemic shortage of engineers, of experienced engineers in the labor market. We know that about 37% of the potential pool of engineers are internationally trained. We know that Canadian employers certainly hire internationally trained engineers. We know that, in fact, for every one engineer that immigrates to Canada as a permanent resident, more than 2 come to Canada under the Temporary Foreign Worker Program. And so the question that we pose to ourselves analytically is what is impeding, what is deterring Canadian employers from taking more advantage of the pool of internationally trained engineers to meet their skill needs. Why is that pool apparently being underutilized? What I want to share with you now is just a few highlights from research that we've undertaken with engineering employers. And this research is based on a survey of 77 engineering employers who collectively employed about 4,600 engineers and about 2,300 engineering technologists. And then that was augmented with 30 face-to-face interviews with engineering employers. And emerging from that research, there's two themes that seem to be important in identifying impediments or obstacles to taking full advantage of the potential pool of talent out there among permanent residents in Canada with engineering qualifications. The first of these has to do with the difficulty of assessing non-Canadian educational qualifications. And you'll see on this graph that 63% indicate that they had a difficult or very difficult, they find it difficult or very difficult to assess non-Canadian engineering educational qualifications. So that's a barrier or an impediment that we need to note. Secondly, we asked about experience, and virtually all employers, 75% indicated that it was very important for applicants to have Canadian engineering experience. And if you add the other 22% who said it was important, then you've got almost the entire survey sample in attaching significance to Canadian engineering experience. And if you flip that, one of the problems that employers have, or many employers, is that they find it difficult to evaluate or understand, but particularly to evaluate, non-Canadian experience. In the survey, 53% of employers indicated that they had difficulty evaluating non-Canadian experience. And among smaller and medium-sized employers, that proportion was substantially higher. In turn, what that often leads to is that you'll see here at the far end of this table, a fifth of the employers that we surveyed indicated that they discount non-Canadian experience, presumably because they have difficulty evaluating it and don't have any other channel that will assist them in the evaluation of non-Canadian experience. Similarly, we find that almost a third of the employers in the survey indicate that they discount non-Canadian references also because they have difficulty confirming those references. We also surveyed employers about the importance of the PEng designation. And what you will see here on this graph is that employers attach enormous importance to the PEng designation. 47% identify it as very important, 29% identify it as important. And so the PEng designation becomes, for many employers, the vehicle that they rely on to evaluate non-Canadian qualifications because of the difficulty that they would otherwise have in judging whether those qualifications are commensurate with Canadian standards.
Thanks so much, John, for that overview. I think it's really helpful to get the background and get a sense of what the labor market trends are in engineering. At this point, folks, what we thought we would do is talk a little bit about the PEO licensing process, because it seems to have some significant implications on the way that job postings are created and what it is that we are asking of potential candidates in terms of what their qualifications should be. And based on some of the employer research that John has taken us through, we see that there are two themes amongst employers. One, that they're unsure of how to evaluate non-Canadian experience, and as well, how to evaluate non-Canadian credentials when it comes to schooling and education and whatnot. So as we go through this PEO licensing process, what we're going to do is also put some signposts up about perhaps the kinds of questions that we can be asking in job postings or interviews, perhaps, that would showcase somebody's strengths and capabilities prior to actually having the PNG. So the PEO licensing process begins with an application that individuals must submit to PEO, and that application for internationally trained engineers must include a copy of their degree, their transcripts, course descriptions, and any details pertaining to their academic credentials. Once that application is submitted to PEO, PEO begins stage one of the process, which involves an academic assessment. Now, this academic assessment is done for all individuals who've studied outside of Canada. People who have studied inside Canada are automatically passed through stage one and move directly to stage two. But for individuals who've studied outside of Canada, their documents are put together and PEO does an assessment by committee to evaluate whether their academic credentials are equivalent to a Bachelor of Engineering degree here in Canada. PEO will not accept any external evaluations conducted by other organizations such as WES, ICAS, or U of T, any of these organizations who do assessments, simply because PEO is setting a standard across all individuals, and so that assessment is done only by PEO. Now, once this academic assessment takes place, there are what I tend to call three scenarios that can come from the academic assessment, and I'll briefly go over what those three scenarios are. Scenario number one is that PEO does the academic assessment, deems the credentials to be equivalent to a Bachelor of Engineering degree here in Canada, and then informs the individual that they can move on to stage two, which is the professional practice exam. So that's scenario number one. Scenario number two is that PEO may call the individual in for a face-to-face interview. And that face-to-face interview, again, is done by committee. And the committee is really assessing the individual's technical capabilities using their experience in past roles, using their work experience, in past roles, to identify whether they feel that their technical understanding and comprehension is up to par with what PEO would deem to be the standard. If the individual passes that interview, they then move on to stage number two. Scenario number three, with respect to the academic assessment, is that PEO will request that the individual do some technical exams. PEO will identify what those technical exams are, and the individual will be required to complete those technical exams before they move on to stage number two. So that's all stage number one. Once an individual has completed stage number one, PEO has approved their academic credentials at that point. So when somebody becomes eligible to write the professional practice exam, this means that PEO has given their stamp of approval on their academic credentials. I'll now talk about stage number two. It's the professional practice exam. This exam is a 3-hour essay-based exam on law and ethics in Canada and Ontario specifically. So individuals are required to complete that exam and pass that in order to be eligible for the PNG. This exam differs from province to province. So I know, for example, in Alberta, the professional practice exam is a 3-hour exam, but it's multiple choice. In Ontario, again, that is essay-based. Something to note is that once somebody has passed the professional practice exam, there's one other component that PEO is looking for, and that is the work experience. And often, many individuals who are writing the professional practice exam have 3 out of the 4 years of required work experience that PEO is looking for. So I'm just going to take a moment right now to talk about what the requirements are around the work experience. PEO is looking for a total of 4 years of work experience from individuals. They will accept a maximum of 3, years of experience from outside of Canada, but PEO will be assessing that experience from outside of Canada to ensure that it actually falls within the engineering discipline that that individual is from. The fourth year of experience that PEO requires is 1 year of experience in Canada under a supervisor who has a PEng. Once an individual has completed Stage 1, Stage 2, and has the work experience, they are then eligible to apply for the PEng designation. So a couple of signposts that I want to put up here on this little diagram here is that, as we're looking at candidates who could potentially fill our roles, one thing that we may want to be asking, rather than asking if they have the PEng, is where they are in the licensing process. What stage are they in? Have they completed the academic assessment? Because if we're concerned about the credentials, if they've completed the academic assessment, which is the first stage of the process, what this means is that this individual is now eligible to write the professional practice exam, and their credentials have been approved. Another thing that we could be asking in terms of stages is, have they written the professional practice exam? If they have, what that's showing is a proven understanding of the law and ethics in Ontario. And generally, when we're talking about internationally trained engineers, as I've mentioned, most internationally trained engineers who have written the professional practice exam, or even who are eligible to write the professional practice exam, have already had their work experience evaluated by PEO, and PEO has indicated at that point that their 3 years are approved, but they're just looking for the 1 year of work experience in order to obtain their PEng. And really the difference between Stage 2 success, so completing the professional practice exam, and actually having the PEng designation for many ITEs is really the 1 year of Canadian work experience. So I just wanted to provide an overview of that licensing process. Again, we have the Q&A pod available, so if anyone has any other questions, feel free to throw a question in the Q&A pod and we'd be happy to answer it. There's one last piece that I'm going to, actually two last pieces that I'm going to mention. Between Stage 1 and Stage 2, PEO also enables individuals to register with PEO as what is called an EIT. So you may sometimes see that on people's resumes or cover letters. What that is intended to do is to inform employers that this individual is in the process of the licensing, in the licensing process, but not yet complete. The last thing that I wanted to mention is the Stage 3 here that I haven't really talked about quite yet. Once people have written the professional practice exam, they also have the option to register for a provisional license with PEO. And the provisional license, again, is another signpost that indicates that all this individual requires is the 1 year of Canadian work experience. Having said that, there is a fee for applying for the provisional license. Many individuals do not apply for the provisional license. And so what we're suggesting is that there are other questions that employers can be asking to determine what stage someone's in the licensing process, and then getting a better sense of how that aligns with what you're looking for as an employer. So I'm going to now pass it off to my colleague Jen, who's going to very quickly talk about some OSPE supports.
Thanks so much, Arthi. So I know we're getting near the end of our time today, and I want to honor your time. So I'm just going to quickly walk through some supports that OSPE has in place for employers. The presentation you've seen today comes from a project called Engineering Your Workforce. This project, as Arthi had mentioned earlier, is funded by the Government of Ontario and the Government of Canada. And one component of the project was a research study, which we shared some of the results of earlier this afternoon. And through that research, we have created a number of resources for HR staff and hiring managers around recruiting, hiring, integrating, and retaining internationally trained engineers. One of the pieces, which I'm going to get into in a moment, is on the HRPA approved workshops. And before I get into that, though, I did want to mention that if you would like more information on some of the resources that have come out of this project, you can visit the website that you see on screen, ospe.on.ca/empinfo. So the one piece I want to talk about is the HRPA approved workshop. What you saw today as the research presentation, that is really the foundation for this workshop. And through that we look at what employers can be doing to ensure that they aren't inadvertently screening out a talent pool. So we have 2 modules which we typically run in a full-day workshop. Module 1 on organizational foundations to build an effective HR business plan, and Module 2, attracting and recruiting engineering talent. Each of these modules is allowed to have 3 CPD hours associated with them. And as I said, we typically run these 2 modules together. Another resource that has come out of this project is the Engineering Employer Resource Hub. And what this is a search engine providing access to a number of resources for engineering employers. For example, a longer version of the presentation you've seen today is available on this website. One thing I do want to note, though, is that when you access the website and the resources on them, there is a login feature when it's time to access a resource. And the reason why that is in place is we do have some rigorous reporting for the ministry, so we do have to keep track of who's accessing our resources. So hopefully you can take a look at the site, and you'll see the link on screen there as well. And one other piece I would like to talk about is the OSPE corporate program. And this is something that has been recently put into place. There are 3 various levels of the corporate program, with each of the levels are differing fees. But included in some of the levels are things like free OSPE memberships for a certain number of employees with your organization, a number of free job postings per year, discounts on professional development courses and events, advertisements with our Voice magazine, or as well as a complimentary copy of the salary survey. And some of the supports that I've listed, we have a slide of information about some of those supports. Including in that, we do also have the engineering employment events, which is something new that OSPE has been running. We just ran 2 successful events in the Toronto area, which were both sold out. At each event, we had over 300 engineers who were either members of OSPE or PEO that were seeking employment. And these are going to be happening all across Ontario within the next year. And lastly, on behalf of Arthi and myself, we'd like to first thank John for presenting another wonderful session. And then we'd like to thank all of you for participating this afternoon. We hope that you found the session to be valuable.